In this video, I'm going to do an experiment to study the behavior of the light emitting diode, or LED. And I've got one connected in the circuit here. Now, something to remember about the light emitting diode is that it is a diode, and therefore it must be connected in the correct way in the circuit. In other words, the positive of the LED must actually be connected to the positive of the supply. And the supply is over here, and I've got two 1.5 volt cells connected in series. And there are 2 meters, a voltmeter here set to measure 20 volts, although we won't need the full range, and over here an ammeter set to measure 200 milliamps. Right, let's take some readings. So I'm going to connect up the circuit now, like so, and we'll start increasing the readings. So at the beginning, the voltage is 0 and the current through the LED is 0. So we'll now go up to 0.5 of a volt, approximately. Now we're not going to set these readings exactly. It's better just to take a reading. There we are, so 0.51 of a volt, and the reading of the current is still 0. Up to 1 volt now. That actually just happened to have landed on 1 volt exactly, and it's still 0. Well, now we'll go up to 1.2 volts, or very nearly, and that is 1.2. And the current now has reached 0.1 of a milliamp. So we'll increase now to 0.4 or thereabouts, 1.38, and it's fluctuating, but 0.1 still. We'll go now to 1.4 and a bit, 1.45, 1.46, 1.47. Let's take it up to a bit over 1.5. So 1.50, 1.51 gives us a still 0.1 of a volt. Let's go up to 1.6 of a volt. Yep, 1.6 of a volt gives us, well, I think 1.2, 1.3. Sorry, 0.2 or 0.3. And I think, well, it really is between the two. I'll take 0.2 for the moment. So 1.60 volts gives you 0.2 of a milliamp. We'll go up to 1.65. And now you have 0.5 milliamps. That's fairly stable. 1.67 and 0.6 of a milliamp. 1.70, and you have 0.9 of a milliamp. 1.75, 1.5, a bit more. We're going to go roughly about 1.8. 1.8 volts, 2.6 milliamps. We'll go out to 1.83, something like that, 1.84. 1.84, and it's beginning to rise sharply now, 3.7. The LED is still almost, I can see a faint glow in it. You may not be able to see that in the camera, but 1.8, 5.3 now, and yes, there's a definite glow now. The LED is on. 1.9, 1.94 or 3, 1.93, and 8.2 milliamps, 1.97, and that's a big jump here, 10.8, and the LED is now nicely on. 2.01 and 13.9 milliamps, 2.12 as 25.5. Now you see now that the current is only just about, it's not quite stable, it's beginning to rise. So I think that's an unstable condition. So we'll run that back slightly at 2.10, if we can get that. Very, very tricky at this voltage and this current. So I'd like to take it at about, well, 2.09. Now, is that stable? I think it is. Right, we'll call that the final reading, 2.09 or 0809. It's fluctuating, but not much. So 2.08, 2.09 at 24.2, and the LED is on. I'm just going to go back to the experiment and have a look at the moment when the current begins to rise, and I've changed the ranges so the voltmeter is now on a scale with a maximum of 2 volts and the ammeter has a maximum of 20 milliamps. And at the moment you see we've got 1.452 volts and a current of 0.02 milliamps, and I'm going to increase it very, very slightly. And at 1.47 we have a current of 0.03, and very nearly 1.5, but 1.499, 0.04, 1.519, a current of 0.05. It's still a rise in current steadily, but at 1.53 it's gone up to 0.07, 1.545, 0.08 milliamps, 1.565, we have 0.12 milliamps, and 1.575, 0.14, 1.591, 0.17, 1.608, 0.23 milliamps, 1.615, 0.25 milliamps, and 1.630, 0.32. And I will stop there for the moment. Before we have a look at the results table and the graph, I thought we ought to look at the LED a bit more closely. Now, I've put it so that you can compare its size with a ruler, and notice that its length is probably about 0.6 or 0.7 of a centimeter, so 6 or 7 millimeters long, with a diameter of about 3 to 4 millimeters. It's a solid state device made of semiconductor material. And now we'll go on and have a look at the table of results and the graph. Now here we have the results table that I obtained from the experiment and also the graph that I plotted using it. Now if you look at the graph, you can see that the LED does not conduct at all until the voltage across it reaches about 1.5 volts, and after that between 1.5 and about 1.8 volts it does conduct, but it's not a linear increase of current with voltage. After that, however, the LED conducts strongly, it lights up, and the current increases rapidly with a very small increase in voltage.